right, so Dmitry Mendeleev was the scientist that proposed that there are certain properties that are going to repeat when we have elements that are arranged in order of increasing atomic mass. And periodic law is the law pertaining to these elements being arranged in order, and we have these certain properties recurring periodically. And on the periodic table, you'll notice that there are a couple of exceptions. So as I move from cobalt over to nickel, you'll notice that the mass is actually going down. So cobalt is 58.93 and nickel is 58.69 atomic mass units. And there are certain names for columns or groups on the periodic table. So these columns are known as groups. They're sometimes called families, depending upon what textbook you're reading or who your teacher is. And some of them have particular names, which you've got to be familiar with. So first what I'm going to do is I'm going to label this periodic table from group 1A over to 8A. You'll notice I skipped the middle, which they all have B's over them, and I'll explain that in a second. Okay, so anything that has an A above its group next to the number is called a representative or main group element. So group 1A, these are called the alkali metals. Okay, and it would be, let me just box in this group so you understand that those are the alkali metals. Okay, the alkaline earth metals are group 2A, and I'm going to box in that group for you. Okay, and then the halogens are group 7A, and then the noble gases are group 8A. Sometimes these noble gases are also known as inert gases because they don't react with anything else because they're stable. Okay, so if you have an element in a group that doesn't have a name, like group 3A through 6A, they don't have specific names, then we refer to them as group 3A, 4A, 5A, 6A. Okay, so those are the groups. Now the periods run from left to right, so what I'm going to do is number the periods. There are 7 of them, and they go from left to right, so those are the rows. Okay, now in the middle we have the transition elements. Transition elements have a B above their group, so these are the transition elements where the B's are. Technically, the B's extend underneath the stair step, which is on the right-hand side of the periodic table. Okay, here your handout is showing you that, I'm going to make a little squiggly line. The transition elements are ending right here where the squiggly line is. Technically, underneath the stair step, those metals are also considered transition elements. Okay, it would probably be a good idea to label the metalloids. So what I'm going to do is highlight them in green. Remember, we learned the metalloids in a previous chapter. Okay. So now you can see the metals that are underneath that stair step that are technically considered transition elements, okay? Okay, now on the very bottom of the periodic table, the inner transition elements are those 2 rows that are detached. So what I'm going to do is just make a note that these are the inner transition elements. Okay, and technically the inner transition elements fit up right here after lanthanum and actinium, which are 57 and 89. So if you think about these 2 rows as being like a flap, you could fold back and just fit right up there. That's what they are. Okay, now the Lanthanide series is this row right here, this top row beginning with number 58, and it goes after La, which is lanthanum. Okay, the Actinide series beginning with number 90. Okay, so this entire series here, this Actinide series fits right up here after 89, which is actinium. Okay, so the periods, which are left to right, are also called a series. And then we've got our rare earth elements. So what I'm going to do is highlight them for you in orange. And then we've got SC, Y, and LA. So these in orange, those are my rare earth elements that are found in the Earth's crust at less than about 0.005% abundance. Okay? Now, the transuranium elements are starting with NP, which is number 93, and everything after number 93 all the way up to number 118, which is not on this periodic table, but it is on the periodic table on the wall. But I'm just going to make a note on your periodic table where 118 goes through. Okay, so everything that I've got in yellow, which starts here with neptunium all the way down, and then starting over here with RF, which is number 104. Okay, and going all the way over to number 118, which I just sort of like wrote in. Okay, those are all of my transuranium elements. Okay, so now, student exercise 1, which group or family of elements does each of the elements belong? So if I'm looking at A, which is magnesium, magnesium is in group 2A, which is the alkaline earth metals. Those metals are not as reactive as the alkali metals, which are in group 1A. Okay. B, nitrogen, that's in group 5A. C, potassium, that's in group 1A. Those are the alkali metals, extremely reactive metals. D, Br is bromine, that's a halogen, it's in group 7A. Student exercise 2, select the symbol of the element that fits the following descriptions. A, the alkali metal in the fourth period. This is the fourth period, these are the alkali metals, it's potassium. B, the halogen in the third period. This is the third period, I go all the way across the halogens, it's chlorine. C, the rare earth with the lowest atomic mass. The rare earths with these orange ones, this would be the lowest atomic mass, it's scandium. D, the metal in group 7B/7 in period 4. Here's period 4, here is 7B, it's manganese. Okay? Okay, so now what you're going to do is the worksheet pertaining to, if I can find it, the periodic table. It's 35 points. It looks like this. It's got fill in the blank, true, false, matching, and on the back there are a few questions, so make sure you carefully do 25 and 26. 25 asks you to look at group 5A and go down and indicate which ones are metals, non-metals, and metalloids. Remember, these are non-metals, the green ones are metalloids, and then anything underneath that would be considered a metal. 26, you're listing the properties of metals and nonmetals, which we discussed in a previous chapter. Like, metals are really good conductors of electricity, nonmetals are not. Nonmetals are really brittle and dull, metals are really hard, etc. Okay? And I think that's about it. I need you to do this worksheet on your own because I need you to start to trust your own judgment and to be able to refer to the periodic table and use it and be confident about it, because that's extremely important as I get into the next chapter. So do it on your own, and if you have any questions, feel free to ask me. Okay? Thanks.